Hey, Algebra 2 students, I had a couple people ask if I would do a video on Module 7.07, Trig Identities. I think that's the title. I know it is Module 7.07. So I told them I would do a quick video and send that out to y'all by email. So one of the things that you do have to bring to the table here is you do have to know your quadrant. So quadrant 1, 2, 3, and 4. You have to know in quadrant 1 your x and your y value are both positive because you move to the right and up. In quadrant 2 your x is negative and your y is positive because you got to move left and up to get to quadrant 2. In quadrant 3 your x and y are both negative because you have to move to the left and down to get into quadrant 3, and in quadrant 4 your x is positive and your y is negative because you have to move to the right and then go down to get into quadrant 4. You also have to know these formulas. Sine of theta is x over r, cosine of theta is x over r, sine of theta is y over r, tangent of theta is y over x, and the formula x squared plus y squared is always equal to r squared. So to do the first few problems, we're going to use all of this knowledge on the right. If you didn't know that, jot it down, take a picture, take a snip, whatever helps. Let's look at what we know. We know that the cosine of theta is negative 3/5, and we know that our angle theta is a symbol for, is a variable that's used often for angles, and it's called theta, Theta. And our angle lies in quadrant 2. So let's go to quadrant 2. If our angle lies in quadrant 2, that means our x is negative and our y is positive. That's going to be important because we're going to have to find out what x, y, and r are, because what they're asking us to find here is sine of theta. So that means we're going to have to find y over r. So we have to know the y value and its sine. Radius will always be positive because that's the radius of the circle. But we do have to find our y here to be able to find what sine is. So take a look at what we know. Cosine is negative 3/5. When a fraction is negative, the negative can either go with the top or it can go with the bottom. Since the bottom is your radius, then your radius will always be positive. So I know this negative 3 has to go with the top. So that means if this is my cosine, x is negative 3, and 5 is my radius. So I know my x value is negative 3. I know my radius is 5. What I don't know is my y value. I do know since theta lies in quadrant 2, I do know that y has to be positive. So I'm just going to do this formula, find out what my y is, make sure that it's positive, and then go from there. So I'm going to do x squared plus y squared equals r squared. That's going to be negative 3 squared plus y squared equals 5 squared. That's going to be 9 plus y squared equals 25. Y squared equals 16. Take the square root of both sides. We know y has to be positive, so we make sure that y comes out to be positive 4. So we know our y is 4. We're looking for sine, which is y over r, so that's going to be 4 over 5. If this fraction could reduce, then you would reduce it. Number 6 is giving us sine of theta is 3 over 8. So again, we're going to talk about what we know and what we don't know. So we are going to need to know x, y, and r in most situations. So I'll go ahead and write those down. Our theta, our angle, is in quadrant 2. That means our x is positive, and our y, that means our x is negative. My bad. If we're in quadrant 2, our x is negative. We're right here. Our x is negative, and our y is positive. And we're looking for cosine. So I always kind of think about what I'm looking for and what I need to find. So cosine is x over r by the formula. Cosine is x over r. So if we know sine is 3 over 8 and theta lies in quadrant 2, sine is y over r. So that means I know my y is 3 and it's positive 3 because I'm in quadrant 2. The y is positive, and my radius is 8. So I don't know my x, but I know my x is going to be negative. So I'm going to do x squared plus y squared equals r squared. Kind of just like the Pythagorean theorem. I don't know x, so I'll leave that as x squared plus 3 squared equals 8 squared. Then it's going to be x squared plus 9 equals 64. Subtract 9 from both sides. That's a 4. X squared is going to equal 55. 55 is not going to be a perfect square, so you're just going to leave x as the square root of 55, and that will not simplify. And we know since theta is in quadrant 2, x will be negative square root of 55. And then cosine is what we're looking for. That's going to be x over r. So you're just going to leave that as the negative will probably go right out in front of the fraction bar. You could put it with a top if you want to, but you'll have square root of 55 in the top, and then you'll have 8 in the bottom. You could put the negative with the top, but don't ever put the negative with the bottom because that's the radius. So either put the negative with the top or put it right out in front of the fraction bar. All right, number 3. Determine the sine of theta when the tangent of theta is 2 square root of 2. And if you're wanting to know, I have 6 examples. So determine sine of theta. So this is another set of formulas. These are called even-odd formulas, where we know sine of a negative theta is equal to negative sine theta. Cosine of negative theta equals positive cosine of theta, and so forth. Every once in a while, they're going to throw a negative inside your parentheses, and you're going to need to go to your reference guide for the even and odd formulas. So again, let's think about x, y, and r. So x, y, and r. If they give me tangent, they're giving me y over x. So they're giving me y divided by x. It's a little bit harder when they give me tangent because it's not just one variable, it's y divided by x, but that's still important information. Okay, so they're giving me y divided by x is 2 square root of 2, and the cosine of negative theta is 1/3. So if we look at cosine of negative theta, that's equal to cosine of positive theta, so we can just go ahead and leave this, change the negative to a positive, and keep what's on the right-hand side according to the even and odd formulas. So that means we know that x is 1. Since I know cosine, x is 1 and 3 is r. And I wrote the wrong thing. X is 1, my bad. And the radius is 3, and so we don't know y. Okay? So we're going to do x squared plus y squared equals r squared. So we're going to do x squared plus y squared equals r squared. That's going to give us 1 squared plus y squared equals 3 squared. That's going to give us 1 plus y squared equals 9. Y squared equals 8. And hold on a minute because I did not get that a while ago. I'm on number 3. Oh, I didn't even have to do this. Hold on. Hold on, wait a minute. Think of a cheer here. Alright, making this harder than it is. Okay, if I know that y divided by x, sorry, I could have done it that way, and I could have gotten the square root of 8, which is 2 square root of 2, but this is a little bit easier. If I know x is 1, so if y divided by x is my tangent, 2 square root of 2, then this is going to be y divided by 1 equals 2 square root of 2. So that means y is going to be 2 square root of 2. So this was the shorter way. I could have done the x squared plus y squared equals r squared. My brain just got carried away. And we are looking for sine. Sine is y over r. So y is going to be 2 square root of 2 over r is 3. And then that would be my answer for number 3. All right, for number 4, it says determine cosine when, so we're looking for cosine, so we're looking for x over r. When tangent, so if we do our x, our y, our r, and then y over x, that's tangent, is negative square root of 3. So kind of sort of the same. They're giving us tangent, they're asking us to find cosine. In the previous problem, they gave us tangent, and they asked us to find sine. So we know tangent, we know whatever the y is divided by whatever the x is negative square root of 3. And then we know sine of negative theta equals negative square root of 3 over 2. So we're going to use, let me scroll up, sine of negative theta equals negative times sine of theta. So that is going to mean that negative, this negative will come out in front. Sine theta equals negative square root of 3 over 2. I'll divide both sides by negative, and that's going to mean that sine of theta is going to equal to positive square root of 3 over 2. That means that sine Okay, this is y, this is r. So that means that my y is square root of 3, and my r is 2. And then if we go down here and we look at tangent is y divided by x, so y is square root of 3 divided by x has to be equal to negative square root of 3. Then x would have to be negative 1. It's kind of like putting pieces of a puzzle together. So we're looking for cosine, which is x over r. So cosine is going to be negative 1 over 2. It might be written like this, or it might be written with a negative right out in front. So you could put the negative with the top because that's the x, but remember radius is always positive. All right, we do have several more formulas. I brought the even and odd formula down here because I think one of the problems I had to use this. We have some Pythagorean identities. Again, these are just rules. These are just equations that we can use to solve problems. We have the quotient identities and the reciprocal identities. And again, I mentioned the even and the odds. So these last two are asking us to prove the trig identity. So we're starting with this. And they're asking us to drag and drop these in order. So this is just what I was taught. So I always start with the side that has the most going on. So I start with this side and I work on this side because the right hand side just has negative sine squared theta and the left hand side has all this other stuff going on. I take the left hand side and I work on it. I do algebra. I use formulas, trig identities, and I try to make the left-hand side look like the right-hand side. So the first thing that I notice on the left-hand side is I have a binomial times a binomial. So if I FOIL this out, first, outer, inner, last, it's going to give me cosine times cosine is cosine squared, cosine times 1 is cosine, negative 1 times cosine is negative cosine, and negative 1 times negative 1 is negative 1 times positive 1 is negative 1. So if I FOIL this out, this will be my first step. This is what I get. The two inside terms are like terms and they are opposites, so they will cancel. And that's going to leave me with cosine squared minus 1. So that would be my second step. And then I'm going to use the identity for cosine squared. So if I scroll back up, it says sine squared plus cosine squared equals 1. So if I subtract sine squared from both sides, that would mean that cosine squared would be equal to 1 minus sine squared. So in the next step, in the place of cosine squared, they're substituting in 1 minus sine squared. So that would be the third step. And then the 1 and the minus 1 are opposites and they would cancel. And that would get me the fourth step, which would be what the right-hand side is equal to. So these are like little proofs. Probably the hardest part about Module 7.06 for most of you are going to be these proving these trig identities. Let's look at one more. Number 6, drag the equations and drop them in the correct order to prove the trig identity. So same concept here. We're starting with this side, 2 times sine negative theta times cosine negative theta plus 1. And then we've got this side, which is a little bit simpler, sine minus cosine squared. So we're going to take the messier side and we're going to do algebra and use our trig identities. And we're going to make it look like the right-hand side, hopefully. So the first thing I see is I see this little negative theta. So I'm going to go up here, and I see cosine of negative theta also. So when these are your even and odds. Did I put these down here? No, I didn't. So if you have sine of negative theta, the negative comes out in front of the sine. And if you have cosine of negative theta, the negative goes away. So that's what we're going to use first. So what's going to happen here is this negative will come out in front of my sine and this negative will go away. So that's going to be this step. Okay, my second step is going to be using, let's see, 1 minus, we're just going to take this 1 and we're going to put it in front. We're just going to rearrange this. And we're going to multiply the 2 times this understood -1. And it's just going to give us 1 minus 2 sine theta cosine theta. So we're just kind of rearranging to get the second step. The third step, we are going to use, well, our last step is going to be this one. That's kind of a given because both sides are going to be equal. Our third step is going to come after step 2, and that is going to be, that sine squared plus cosine squared, that's one of our Pythagorean identities. Sine squared plus cosine squared equals 1. So we can take this plus this and turn it into 1 and then keep this. And then it gets us to our, this gives us, I'm on this one. Sine squared minus 2 sine cosine. This is actually a trinomial plus cosine squared, and it factors into sine of theta minus cosine of theta times sine of theta minus cosine of theta, which would be sine minus cosine squared, which is what we're trying to get the right-hand side equal to. You might have to watch this video more than once. I know I was talking fast. I was trying to get through 6 examples. Again, this is just a quick help video for Module 707. If you have any questions, let me know.